A small block slides without friction down an inclined plane starting from rest. So u equal to 0. Let Sn be the distance traveled from t equal to n minus 1 to t equal to n. So this is called distance travel in nth second. So suppose that in n second distance travel is this. This is called Sn. Okay, and in n plus 1 is going here to here. Okay, so the S n plus 1, suppose that this distance. So this distance is called this here to here is a Sn. So like distance travel in nth second. Here is given Sn, you can write formula like this. So Sn equal to distance travel in n second minus distance travel in n minus 1 second, and you know the formula of Sn equal to ut plus half at square. But here the ball is sliding in inclined plane. So suppose that if you have a inclined plane, the ball is sliding. So this angle is theta. You know, in this direction always act g. So in this direction g cos theta, and in this direction g sin theta. So instead of g you have to substitute g sin theta, okay, for the inclined plane, and there is no friction. So now if you put here u equal to 0, so the Sn distance cover in n second equal to half g sin theta into n square. So you can put here, so this will be half g will be g sin theta and t square will be n square here. Similarly, distance travel in n minus 1 second, you can write half g sin theta into n minus 1 square. So if you just simplify this, half g sin theta will be common, n square into n minus 1 square, this will be 2n minus 1. So n square 2n minus 1. So what we need to find out? S5 by S6. So S5 by S6. S5 we have to put n equal to 5. So 1 by 2 g sin theta will be common in both, so it will cancel out. N we have to put 5. So 2 into 5, 10 minus 1, it will be 9, and 6, 12 minus 1 is 11. So the S5 by S6 will be 9 by 11. Okay. The next question is, a boat which has a speed of 5 km per hour in still water and a speed of river is 3 km per hour. The width of river is given 1 km. The time taken to cross the river along the shortest path and shortest time are T1 and T2 respectively. Then T1 and T2 are. So you know this type of question. So suppose that you want to cross the river, okay, and the river width is given 1 km. Okay. So for the shortest time, okay, for shortest time, the boat should go exactly perpendicular to the direction of river. So river is flowing in this direction, that is given 3 km per hour, and for the boat, speed of boat is given 5 km per hour. So for the shortest time, boat should head A to B. So it means net speed of boat along AB, that is a velocity of boat, that is a 5 km per hour plus 0, because the river is flowing in this direction. So in this direction, perpendicular direction with 0 component. So the 5 km per hour. So the time taken, like a T2, shortest path will be AB upon velocity perpendicular direction. So the 1 by 5 this hour divided multiply by 60 minutes. So that is a 12 minute. So the shortest time will be 12 minutes. What about shortest path? So for the shortest path, what you have to do? This is given A to B. Okay. So this is the velocity of river and this is given velocity of boat. Okay. Not direction. So suppose that this is the direction of boat. I am selecting theta with the AB line. Okay. So now the velocity of boat in this direction will be VB sin theta and the perpendicular direction VB cos theta, and in this direction is given velocity of river. So the time taken T1 for the shortest path will be AB by total velocity along the AB direction, that will be the VB cos theta. So we know AB is a given 1, B is a given 5 cos theta, but we don't know the value of cos theta. But you can see in this direction shortest path, it means for shortest path it means the boat should start from A point and reach at B point. So exactly A to B. Okay, so there is no displacement along river. Okay, so the net velocity like along the river VB sin theta minus VR equal to 0, because there is no displacement in this direction. So net velocity should be also 0. So the sin theta equal to VR by VB. So this is 3 by 5. So what about the cos theta? So you can find the cos theta equal to 1 minus sin square theta. So 9 by 25, that is 4 by 5. Now you can put here. So the T2 equal to 1 by 5 and cos theta is 4 by 5 multiply by 60 minutes, because I am converting into minute. So the 15 minute. So the answer is you can see here T1 was here is a 12 minute, T2 this is a 12 minute and this one is a 15 minute. So the answer is a C. So now you can see, you understand, try to understand once again here. For the shortest path, we have to start from A and reach at point B. So there is no displacement in x direction. Suppose that this is the x direction, so displacement in x direction will be 0. So net velocity in x direction, like a net velocity in x direction should be 0, and then you find the theta angle. But for the shortest time we have to go exactly, we have to follow the path and maybe we can reach in somewhere. Okay, so that is the reason we have to take the velocity of boat only in this direction. That is the shortest time we will take. So at any time boat will head perpendicular to the flow of river. So in this case we have always say AB divided by velocity of boat here for the shortest time, T minimum. And then sometime they will ask also how far from the B point, like A and B. So then this distance travel by the velocity of boat only, velocity of river only. So the BC is equal to velocity of river multiplied by T minimum. This will give you information where boat is going to land. But for the shortest path, always start from the A point and reach at B point. So the distance covered, the B and C will be coincide. So BC will be 0 here. Okay. Question is, in given velocity displacement graph, find the acceleration A at s equal to 0. So you know velocity and position graph. So dv by ds, what will give? So you can write here dv by dt, and you can write like this, dt and multiply, I divided here. So dv by dt, you know this is the acceleration, and ds by dt, this will be the velocity. So slope in velocity displacement graph always give the ratio of acceleration and velocity. That is important point here. Okay, now go through graph actually. So what is slope? So slope will be, suppose that this angle is a theta. So you know tan theta equal to 20 by 20, that will be the 1. Okay, so you can find theta equal to 45 degree, but slope is not 45 degree. So what about the slope? Slope will be tan pi minus theta, because suppose this is theta, so this is the slope, because slope always from x-axis with anti-clockwise direction. So the pi minus pi by 4, that will be 3 pi by 4. Now we just equate the two, the first equation and this is the second, because this is a slope here, dv by ds. So you can write a by v equal to 3 pi by 4, and you know what you have to find a, and v is given because v at s equal to 0, s equal to 0, v is a 20. So a equal to 3 pi by 4 into 20. So this is a 15 pi meter per second square. So if you have like a standard like a velocity and displacement curve, then you can always dv by ds, slope will give a by v. But suppose that if you have a, here is a given v square, okay, and the same, suppose that 20, and here is also given 20, velocity and position graph, then you have to find actually what about the slope. So dv square by ds, so differentiate this one, so 2v into dv by ds, and as you see dv by ds, you know dv by ds equal to a by v. So here you can put dv into dv by ds is a by v. So v cancel, this equal to 2a. Now you can equate 2a with whatever value we will get from here, like there was a 3 pi by 4. So you can put here 3 pi by 4. So a will give in here 3 pi by 8 meter per second square. So sometime v square, sometime v cube, but in this way we have to go. First find the slope. Okay, standard one we know dv by ds. Okay, but if you have dv square by ds, just differentiate it like a 2v into dv by ds and just equate whatever you have. So there are two methods. First take the differentiation method, and another find the slope by the angle method, and then equate it and find the value of whatever you want.